Good morning, everybody, and thank you all very much for coming. I'm really, really pleased, excited, and as we've just talked, it's all about you interacting, questions, and our capacity, not that we've got all the answers, but at least to explore where we're going, where the potential is. So look, thank you all, and thanks Land Services and everyone for organising it, and I feel honoured. Just a bit of background. I mean, as I mentioned, I'm a soil microbial ecologist, innocent bystander from down under. You walk across me all the time. And basically, I was working initially as a young scientist in CSIRO, Tropical Crops and Pastures in Brisbane, but also up in the Cape and Katherine and Northern Australia. Very interesting project looking at how do we actually solubilize natural soil phosphorus to get bioproductivity in that 300 million hectares of rangelands that we've got to manage. It was funded actually quite significantly. This is all in the mid-70s by the Reserve Bank of Australia, because they said that this is critical to anchoring the long-term productivity and resilience of that country. So they were astutely aware. There had been an oil crisis, of course, the OPEC oil crisis, and so phosphorus was no longer affordable, and so it was a question of how do we use nature, how do we use microbiology, the natural processes of solubilizing, taking up, and then making nutrients available. Can we use that rather than a more-on fertilizer approach, which was, of course, unsustainable? I also then worked a long time with a division of soils, looking at, regeneration of degraded landscapes, because, we've got 5 billion hectares of man-made desert and wasteland on this planet. There's only 14 billion hectares of ice-free land, so we've already screwed up 40% of the land area, turned it to desert, whether it's Sahara, Saudi Arabia, parts of southwest US, and in a sense, what can we do to regreen and rehabilitate? I then left science because science became pretty a dog's business of just chasing money and contracts, and actually started working with the government, federal government, John Button, Keating, etc., John Kerrin, and looking at future industry strategies, right? Like how do we get beyond just agriculture as a commodity provider, producing commodities, just extractive mining, in a sense, the soil heritage of Australia, and how do we actually build viable value capture industries. And it's really quite significant because that's, in a sense, the crisis and a really big challenge, also massive opportunity that we face, but we don't talk about it. We're still basically largely producing commodities for 6 cents in the dollar on average, and hey guys, you've got to be 40 cents in the dollar minimum. And so how do we get there? We can do it, but what is it that we have to do to get to that journey? I retired about 20 years ago. I'm quite old. And basically, and we formed this little group with innovative farmers Australia-wide called Healthy Soils Australia, and then Rudd came along with basically that whole discussion of climate and so on. And we're very much at the forefront of, hey, it's not just carbon drawdown and carbon accounts, it's actually putting that carbon back into the earth soil carbon sponge, right? And so that's the real take-home message. It's regenerating the earth soil carbon sponge. Sponge is important because with that sponge, we get water. You see? And then that's so important because basically it's hydrology, it's water that sustains life, it sustains productivity, and it's actually aridification that's the biggest danger for agriculture particularly. So it's really building that water capital through regenerating our soils. So the carbon is a tool, it's a point of agency that we need to rebuild that sponge, to rebuild our hydrology and resistance. That water is also now, because we've screwed around for 30 years doing nothing, that water now is the only means we can naturally, safely cool the climate. 95% of the heat dynamics of the blue planet is governed by water and some very sophisticated, beautiful natural cooling processes that we can enhance and restore and cool the climate. But we're not going to get there just by emissions trading. We've got to actually build that sponge. 1 gram of carbon can store 8 grams of water in that soil. 1 gram of organic matter, which is 50% carbon, can store about 4. And of course, thank you very much. That's in a sense data that indisputable. We've known about it, but we've got to get that across. We've got to build that sponge. We've got to build that water, because that rehydration of landscapes is going to be the critical point of action and agency we must do. Which actually brings us back to, now 2024 and the next 10 years. And the real issue is, climate change, right? Because we're past, here's temperature rising, here's CO2 going, but we haven't done anything about that. But what's happening now, we're going into decades of dangerous, intensified hydrological extremes. You're seeing that Andalusia, Spain, flash flooded, hundreds of people dead, but more than that, the whole agricultural resilience of that system is crashing. You in agriculture, you don't see it, you do know it, but the point is you need enough time and reliability and regularity to have a crop or to put a 500 kilogram animal off into the market. And you can't take these dangerous hydrological extremes, okay? And they're the things that kill you, because they're the things that are the floods, the erosion, the cost, the risk, the damage. And if you're getting these extremes every couple of years, you can't pay your interest on your overdrafts because your yields and your returns aren't there, and the bank will cut your throat. Okay? So it's a guaranteed failure thing, because with these extremes, this variability, unpredictability, you're extremely exposed. And so what you have to do, you have to build buffering and resilience. Okay? You've got to say, look, how do I use my land management to actually build buffers against these hydrological extremes? And basically, how do I build resilience in my food system so I don't become vulnerable to the bank, foreclosing me, cutting my throat, selling it off? And so the thing and the only thing you can do there to do that buffering, that resilience, to face the reality that we can't escape, is to regenerate the Earth's soil carbon sponge. Okay, so this is just so critical. And you've got perhaps a decade to look at yourself, look at your business, and look at your management and saying, right, how vulnerable am I? And I can illustrate that perhaps best in a little diagram, right? And it's called a hydrograph. And it just means water flow over time. And look, any engineer, anyone understands that. Hang on, we should turn that board up so everyone can see it, right? And obviously, if we've got a soil concreted catchment, which in a sense is what we've done after 200 years of agriculture, with an average of 0.3% carbon in that soil, and if we just get a very simple thing, a 50 millimetre rainfall event, what happens to that water over time? And so basically, we end up with a flood peak, and then it very quickly drains. And of course, in that flood peak, we call that a flood. But this is where we have all our erosion. Hey, we don't have any topsoil because that went down the creek. Okay, we've got massive costs, not just because of the erosion and the damage on farm, but just think of how much we as taxpayers pay for civil concrete infrastructure, for stormwater, dams, etc., repairs, road repairs. Massive costs, of course, massive risk. You try and insure against these flood peaks and just see what the insurance premium has to be. You can't cover it. Okay, so this is really just, basically loss. You're just losing big time. But that's nothing, because what that flood peak has told you, by design, you have locked in the next thing, which is called drought. GHT, because in a sense the water that went down the creek is water that you haven't got. And guess what? You've got erosion, because now it's wind erosion, you've got massive more costs, you've got massive more risk, you've got massive more losses. But what you end up, of course, is worse than that. You then end up with things like wildfires, okay, and everything oxidizes back to CO2. Okay? And this is the whole point, that you've spent your whole business model say, look, there's sunshine, there's CO2, I've got plants, and I can manage those to create food or plant biomass that I can put into animals, that I can build a business of. But you've screwed the whole thing, and you've guaranteed basically death. Okay? And we all die, so why bother? We can go along with it, right? But the point is that you're going to die. You can't make that system work. And as climate extremes intensify, that grinder is going to get us, right? And you can't avoid it, but you can avoid it. So let's go into green, because we're not political, but basically green's good. And if we simply increase, like Glenn does, not 0.3, we increase it to, look, this, I'm Freudian, I'm buggered up. If we increase that to 3% carbon, right? And this is Glenn's work from before. Sorry?
You got 30.
Oh, my goodness, yes. No, I've got a point there. Hey, I've got a point. 3% carbon, right? And no big deal, we just increase that thing. What happens, and again, everyone understands it, there's no dispute about it, science, physics, whatever. We get a completely different hydrograph, because the same volume under that graph, we will now get a flow curve like that. We still will lose some water, they will still run off into the creeks. But basically, the flood peak will be different. But now something very profound happens. Because instead of just having water in our soil, there's a vent for just say 10 days, and then it's dry, and then we're back to sort of whinging about we are not getting enough rain. We now have a growing period with this longevity of green that might be 200 days. Okay, and this is now the point. We are going to have longevity of green. And see, Jason was telling me, look, this is the pastures that I'm growing and business with, but it's not how big things are, how fast. That's male, right? History. It's time, it's longevity, how long things are growing. Nature doesn't try and beat itself, it just keeps on growing. And this is profound, because whereas we had 10 days now, we have 200 days. That's a 20-fold difference. 20-fold difference. That's 2,000% growth response. When I was in Siren, we had a 30% growth response because somebody did miraculous. We put on a clean lab coat, get a clipboard, and queue up for a Nobel Prize. And here's 2,000% growth responses that are available for you. Okay? So this is really powerful, because that is giving you productivity, resilience, because you're now using that sponge and the in-soil reservoirs that it generates to hold that water to sustain longevity of green. We won't go into it in detail, but basically another group of smarties, Andre Vossen, 1950s, and then Alan Savory picked it up and commented. They sort of said, if I've got longevity of green, I can grow pasture, I can harvest it, half of it, I get cattle to eat it, I grow another pasture, harvest half of it, And they can get, in a sense, 10 feeding cycles on that 200, or not quite 10, just say 6 or 7 feeding cycles on that 200 days of pasture green. And every cycle, they're pumping carbon back into the soil, because you know that 60-70% of the biomass you produce is there as roots and root exudates, pumping carbon back into the soil that you can, of course, use directly to build the sponge. So you don't have to even build the sponge. You can get it done for nothing. Okay? So good ecological grazing management. Okay? But look, there's a massive productivity dividend you're getting. Again, it's not today's talk, but you've got another thing, that all that growth, all that longevity of green is, of course, transpiring water up into the air, isn't it? Okay? So all that longevity is doing transpiration of water into the air. To transpire, we've got to turn water from a liquid into a gas. It takes 590 calories of energy, heat energy, per gram to do that. That's the latent heat of vaporization. So in transpiring, that water is taking heat from the habitat and bringing it back into the atmosphere, cooling that habitat 590 watts per square meter. And that's how the planet cools itself. 24% of the incident solar radiation we get continually from the sun is naturally transpired back up into the air and then out to space through this latent heat transfer, natural hydrological cooling. We're going to be worried about cooling soon because we're overheating. So how do we rebuild cooling, resilience, buffering? Hey, it's all there. And you're getting carbon in your soil for nothing. Okay? So this is so important. Now, I'm a soil microbiologist, and my guys, the fungi, the bacteria, they've been doing this for 420 million years on land, forming soils, building the sponge, building hydrology, sustaining green vegetation all across the planet, and then cooling the planet and governing its climate. I mean, we can go further. That water, when it goes into the air, gets what? It forms these things we call clouds. And of course, clouds reflect 33% of the incident solar radiation back to space, so it doesn't even get to the surface. So 24% heat uptake through that latent heat, 33 there. So over 50% of the incident solar radiation on the planet is actually cooled naturally, hydrologically, but only if we have a sponge. Only if we have land systems that are sustainable and green. So you guys, you don't know it, but really you are the stewards, the custodians of the land and the future. Okay? Because you're the ones that govern the hydrology, you're the ones that govern the climate, and of course in growing that green grass and putting it into animals, you're also producing food security. When I started in this research science, in the 60s, we had 3 billion people on the planet. By 2050, the projection is 10 billion. But of that 10 billion, 6 billion will be, in a sense, subclinically malnourished and miserable because of the food, not just the quantity of food. Yes, we can produce quantity, but we don't produce the quality of the food. We don't have food with the nutritional integrity that gives us our essential health necessities. And so again, we're going to go into the next decades where, in a sense, it's health that matters. Okay, so we've got sunshine, CO2, we've got plants, we've got farmers. They're critical at the front end, basically producing quality food, but they need nutrients from the soil. And those nutrients basically have to be in the right forms, in the ratios and balances So the plants are healthy, the animals are healthy, and we are healthy, because that's how we've evolved. We've evolved on that food chain. And so we've got to make that sponge so that it makes that nutrient available in that complex natural integrity format, the right forms, ratios, and balances, because that governs our preventative health. And in a sense, we in agriculture have to accept we're not in the grass business, we're not in the cattle business, we're not even in the food business. We're in the human health business. We're in making sure that people are healthy and can live and reproduce and have, meaningful, healthy lives. And to do that, it's the nutritional integrity of their food. Not the density. Anyone can throw more on into the food, but it's the integrity, the right forms, ratios, balances. We all need about 40 essential nutrients in the right forms, ratios, and balances, which come from healthy soils, from the fungi and the microbes in the soils producing that. And so you are the custodian of human health. Now, the criminal thing about it is, hey, you're getting screwed because you're getting 6 cents on the dollar on average. I mean, the figures are very simple. We can take all this misery away. The figures are very simple. Basically, we have globally a $10 trillion per annum industrial food system. And you as farmers, we'll do it in red because it's miserable, you and farmers get about 2 trillion of that, but you're paying about 1.3 trillion as input costs. That's your fertilizer, your biocides, and not even looking at the bank overhead costs. So you're getting, 6, 7 cents in the dollar. But it's worse than that, because that $10 trillion now also drives another industry, and that industry is even bigger, $20 to $30 trillion per annum, and that's the industrial disease industry. Okay? That's industrial-driven diseases because of the shit that we're eating. The compromised food that doesn't have the nutritional integrity. So we've got, cancers, we've got autoimmune, we've got diabetes, we've got all these diseases impacting communities. Young people, sure, old people like me can get cancers, but basically why are people at 20, 30, 40 getting cancers? And we've now got this reality where, 60% of us are subclinically malnourished because they're not getting the quality food. And the point is, instead of getting your 6 cents in the dollar here, you've got to move up there and you've got to go into the health business. And basically you've got, 5 billion women. At least 2 billion of them are astute enough and know and understand that I must give my children the very best nutritional chance. They're empowered because they are spending money on buying food. Every dollar they spend on food is a vote for integrity. And so this is, in a sense, a relationship. We've got to go back to health, and we've got to go back to these consumers, these informed consumers, and we've got to say, hey, we need a partnership because only you can produce nutritional integrity that goes to those health outcomes. And so this is, in a sense, a massive opportunity, but it's the only future agriculture's got, because in the next 20 years, you're either going to die. If it's not from climate change, if it's not from the banks foreclosing, you're not going to survive on 6 cents. You've got to move up that value chain. You've got to build relationship with these consumers. And the beautiful thing is you can do it all by simply growing the Earth's soil carbon sponge and getting your carbon in the soil for nothing as kickbacks. So look, I'll leave it with that. So it's about regenerating your earth, soil, carbon sponge. The key thing you've got to look at is rehydrating your landscapes, so resilience and buffering, and then re-innovating your value chains, realizing that you are the stewards, you are the future, you are critical for that health outcome, and making sure that you get a slice of that action. So thank you very much.